Today we will start a new chapter that is on vector algebra. Okay, we will start. There are some simple things like the addition of vector, subtraction of vector, then multiplication of vector. In multiplication, there are two types. One is dot product, one is cross product. So dot product gives rise to a scalar and cross product gives rise to a vector. So let us start with the definition of vector. Okay, actually what is a vector? Like we say, velocity is a vector, acceleration is a vector, force is a vector. So vector is something which has some magnitude, also some direction. Okay, mass is not a vector; it is not related to any direction. But force, you want to know in which direction this force is being applied. Okay. Similarly, velocity is a vector. See, there is a difference between speed and velocity. When you are telling, okay, my car is moving at 80 km per hour, that means its speed. So velocity means I am moving at 80 km per hour in the north direction. That means when you associate direction with speed or the magnitude, when you associate magnitude with direction, that is called a vector. Okay. So the definition of vector, a quantity that has magnitude as well as direction is called a vector. Okay. A quantity that has both magnitude and direction is called a vector. Right? So okay. So So I have given you the example like force is a vector, velocity is a vector, acceleration is a vector. Okay. So and there are different something called suppose you know let us say there is a point xyz in the 3D. Okay, so let us say you have some three dimensional plane. Okay, so you have a three-dimensional plane. Let us say this is my x. Let us say this is my x, this is my y, and this is my z. Okay, let us say I move some distance x. Okay, in the x-axis. Okay, then let me say I move some distance y. Say after moving x, I move some distance y. That means it is now in the 2D. It is in the 2D. Okay. So let us say I move perpendicular to the direction of the perpendicular to the plane of this board. So you imagine that there is some point in space. Okay. So this point is xy. Okay. This point is xy. But if I move a distance perpendicular to the plane of the board, which I am not able to represent here, uh, let us say, this is xy, and let us say it has moved by some distance z. Okay, it has moved by some distance z. Let us say, like we can represent it by something like this. Let us say this is x, then let us say this is this, and this is this. Okay. And say I have moved something like this. Okay, then I'll come to a point like this. Okay, I'll come to a point like this. Then let us say something like this. Okay. Then let us say I'll draw some parallel line, something like this. Okay. Then let me draw some. Okay. So this point. Now you can imagine this is a like a rectangle or whatever. It is not looking exactly like what we are intending to do, like something like this. So this point we has moved z in the third plane. So we have 2D plane. Now it is in the 3D. This point is in the 3D. So this point has a coordinate x, y, and z. So this is a point in space. Okay. So let us say this point is P. Okay. So this point is P. That means this is called like so the position vector of the point P. Okay. So what is the position vector of this point P? That position vector, suppose it will start from O and it will go till the point P, right? Yes. So this is my point OP. Its magnitude will become x square plus y square plus z square square root. Yeah. Because you just imagine if now it is not moving in z direction, if it is only in xy plane, it would have become x square plus y square square root. Right? Mm. Now if it is moving in z plane, it's x square plus y square plus z square. So this is the point. So a point with respect to O, so initial point and final point is called position vector of U with respect to O. So this is nothing but your distance formula, right? What is distance formula? So you know point actually if a point has a coordinate x, y and z, and this is the point coordinate x, y, z. Your original coordinate is 0, 0, 0. Yeah. Okay. So you know distance formula, it is nothing but like say OP, what is the magnitude? It will become x minus 0 square, right? Right? Plus y minus 0 square plus z minus 0 square. Okay. Yes. So the thing, this is nothing but your x square plus y square plus z square. So this is nothing but your distance formula. Yes. Okay. So this so here O is the initial point and P is the final point. So it's a vector OP, right? So in a vector, when we say a vector AB, that means A stands for the initial point, B stands for the end point. So in this case, O stands for the initial point, P stands for the end point. Okay. Okay. So so using distance formula, the magnitude of OP or R. So the magnitude of vector OP is this much. Yes. Okay. O is the initial point and this thing. So vector OP and its coordinate x, y, z. In practice, position vector of points OBC with respect to O are denoted by A, B, C or whatever. Okay, so now we know that, and there is something called the direction cosine. Okay, so what is direction cosine actually? This we can otherwise called as R. Okay, this magnitude we can otherwise called as R. Okay, x square plus y square plus z square root. Okay, this is the magnitude. Okay. So the direction cosine of what is the direction cosine? That means cos alpha, cos beta and cos gamma. Okay. So let us say it will have a direction cosine in x with x-axis what angle it is making, with y-axis what angle it is making, with z-axis what angle it is making. So let us say when it is in xy plane, it will make this point with x-axis, it will make angle alpha. Okay, so angle made by OP with x-axis is called alpha. Okay. Similarly, angle made by y-axis made by OP with y-axis is called beta. Similarly, there is another angle called gamma, that is the angle made by OP with the z-axis. Because this is in 3D, okay? This is in 3D, that's why we will have three angles. So what is direction cosine? If you take cos of the angle, that is called direction cosine. Okay. So it will tell you the direction. Like there are three direction cosines for 3D, a point in three-dimensional space. There will be two direction cosines for a point in two-dimensional space. Okay, so these direction cosines we can find by the formula for direction cosines is nothing but your x coordinate divided by r. So this is just an angle, so it is not a vector, just two magnitude. Okay, so if you know the x coordinate and if you know the r, x square plus y square plus z square, so that is the cos alpha. So you can find the angle by alpha is equal to cos inverse of x by r. So that's how you get an angle. Okay. So if you know x coordinate and if you know x, y, z coordinate of a point, you can find the angle, right? So alpha, cos alpha. Similarly, there will be cos beta. Okay. Cos beta is equal to y by r, right? Cos beta is equal to y by r. Similarly, cos gamma is equal to z by r. So these are called direction cosines. Okay. And again, one more important thing you should remember: the sum of square of direction cosines is equal to 1. L square plus m square plus n square is equal to 1. So the sum of direction cosines is equal to 1. So L square plus m square plus n square is equal to 1. So L is nothing but your cos alpha, m is nothing but your cos beta, n is nothing but your cos gamma. Okay. So this is about the direction cosines, and okay, so this is about the direction cosines. This you need to remember, like if there is a point in space x, y, z, so the magnitude or the distance, so the distance formula we can use, and the distance, the magnitude of that vector OP is equal to the magnitude of vector OP is equal to square root of x square plus y square plus z square. That is the magnitude of vector OP. Similarly, you can find out its direction also. Okay. So alpha, beta, and gamma, you can find out its direction also. Okay. So this needs to be remembered. L square plus m square plus n square is equal to 1. And suppose somebody want to find out what are the alpha, beta, and gamma. So alpha is nothing but cos inverse x by r. So cos alpha is equal to x by r. X is the x coordinate, r is the square root of x square plus y square plus z square. Okay. So that is cos alpha. Similarly, cos beta is y by r. Cos gamma is equal to z by r. So if you want to find the angle alpha, beta, and gamma, you can easily find it. So to show it in a better way, so let us say this is your 3D. Okay. So this angle, this is your point P. So you project this point P on this Okay, so this is your point P. So this angle is your alpha, this is your x-axis, and this is your y-axis. So with the y-axis it is making beta, and then now you move your this line perpendicular to the vector. So you will get another angle that is called gamma. Okay, clear? Clear now?
Yes.
So direction cosines you understood,
Yes.
and a point in space you understood, and vector is a quantity which has both direction and magnitude. So we will study about dot product and cross product. We will study about addition of vector, subtraction of vector, multiplication of vector. In multiplication there can be a dot product, there can be a cross product. So dot product is a scalar, cross product is a vector. So all those things will study. Okay. So there are different definition of vectors. Okay. So one is zero vector. Okay. One is called zero vector. Okay. So zero vector. So a vector whose initial and terminal points coincide. So let us say AB vector.
Magnitude is
AB vector is a zero vector provided it is just a point. If initial and the final point coincide, that is called a zero vector. Okay, and it is denoted by zero vector. Okay, zero vector cannot be assigned a definite direction, and it's you don't know what is a point. You cannot say what is the direction, right? But on average, it may be regarded as having any direction. So it can have any direction. So vector A, so vector A or vector B, these are all zero vector because it starts with point A, ends with point A. Okay, then there is something called unit vector. Unit vector. Okay. So unit vector, a vector whose magnitude is unit, is called a unit vector. So unit vector is direction of a given vector A is denoted by A. So unit vector is a direction of a given vector A. So a vector whose magnitude is unit is called unit vector. Okay. Then co-initial vector. So two or more vectors having same initial point are called co-initial vectors. So if you have a vector like this and you have a vector like this, let us say A, this is B. So this is called co-initial vector. Co-initial vector. That means both these vector A and B are starting with the same point, same origin. That is called co-initial vector. Then equal vector. When you tell that two vectors are equal,
they have
same direction and same magnitude. Let me say if this is a vector and then let us say this is a vector. Okay, so this vector, if both are having say vector A and let us say vector B, if both are having same direction and magnitude, then they are called equal vector. Two vector A and B are equal if they have the same magnitude and direction regardless of position of their initial point. So it's not necessary that it has to be, so wherever it may be. It can be here, it can be like this also, but it has to be parallel and it can start from any point, does not matter. But if the magnitude and direction are same, they are equal vector. Okay, and then negative vector also. A vector whose magnitude is same as that of a given vector, but direction is opposite to is called negative vector. So yes, so negative vector. Okay, negative vector. So if this vector is like this, then another vector is like this. If they are just opposite to each other, they are called negative vector. Okay, so okay, so there are some examples that we can discuss, like the first example. So represent graphically a displacement of 40 kilometer 30 degree west of south. Okay. So we know this is our map, the way we represent. So this is my north. Okay. This is my south. This is my east, and this is my west. Okay. So this is what it is. So the question is represent graphically a displacement of 40 kilometer 30 degree west of south. Okay. So 30 degree west of south. Okay. So first I know this is my south. So if I go in this direction, this is east of south. If I go in this direction, this is west of south. And so I have gone 30 degree. Let us say this let us say this angle is 30 degree. Okay. This angle is 30 degree. Okay. So if I measure, like say a displacement of 40 kilometer 30 degree west of south. Okay. So if this point is O, and let us say this point is P, and if this distance is 40 kilometer. Okay. So if this is the case, so this is a vector which is 30 degree west of south, and its magnitude is 40 kilometer. So in this case it is a displacement. It is not a distance. So in your motion, whatever you have studied, there is a difference between displacement and distance. Okay. So if I say only 40 kilometer, so it can be in any direction. So distance can be in any direction. But when I am assigning a direction and with the magnitude, that becomes a displacement, and that is a vector. Okay. So that is it. Then classify the following as scalars and vectors. Okay. So 5 seconds. It's a scalar or vector?
5 seconds is a scalar.
Because it does not have any direction. Okay. 100 centimeter, 1000 cm cube. It is a scalar or vector? Scalar. Because it's volume. Volume is 1000 cm cube. That means it's just a volume. It does not have any direction. Okay. 10 Newton.
That has
it's a unit of force. That's why it is vector. Because force means you should know in which direction you are applying the force. Okay. So 10 Newton is a vector. Similarly, 30 kilometer per hour.
That is also
vector or scalar?
30 kilometer per hour. No, that is a scalar.
Scalar, because
it
is a speed. It's not a velocity. So if you are moving 30 kilometer per hour, just you are telling that it is speed. But if you are saying 30 kilometer per hour in north, that means it's velocity. So speed. So with vector and scalar. Okay. So we know, like say, let us say start with scalar and vector. Okay. So distance is scalar, but displacement is vector. Right? Correct?
Yes.
So then speed is scalar, but velocity is vector.
Yes.
Both the things are same unit, but one is
direction.
And then all these things like the density, mass, so all these things, the mass, density, all these things are scalar only because they don't have any direction.
Yes.
Mass, density, but force is scalar.
Vector.
Because force is nothing but mass into acceleration.
Gives both
So
direction
yeah.
and
So when you multiply a vector with a scalar, it becomes a vector.
Yes.
That's what it is. Force is equal to mass into acceleration.
Yes.
So when you multiply a scalar with a vector, it becomes a vector. And then another example they are telling 20 meters per second towards north. So something is moving 20 meters per second towards north. That is a vector because you are associating a direction to it. Okay. So you know collinear vector and then equal vector and co-initial vectors and all that. Okay. So we have discussed now like what is equal vector. If they are of equal magnitude and equal direction, irrespective of the starting point. That is equal vector. And collinear, if collinear vector, two or vectors are collinear if they are parallel to the same line, okay, irrespective of their magnitude and direction. So if this is a line, so two vectors are collinear, means this is one vector A and there is another vector B. They are on the same line, that's why they are collinear.
Yes.
If they are on the same line, that means two vectors are parallel to a single line. So they are on the same line.
Same.
That is collinear vector. Okay. So co-initial vector if they starts from the same point. That is called co-initial vector. Okay. So there are some examples. 5 examples are given. Exercise you can solve that. Okay. So now with this giving the definition of vector and discussing about the direction, cosines and the distance, using distance formula, how to get the magnitude. Now we will go to the addition and subtraction of vector. Okay. We will go to the addition and subtraction of vector. Clear till this point? In statics, we used to draw the free body diagram. So we used to remove the support and we used to find out what are the forces and reactions acting on it. And in statics, the net force is equal to 0 and net movement is equal to 0. So there we are studying about this addition of vectors. Suppose there are 2 forces acting on it or 3 forces acting on it. So after all it will form a closed triangle or whatever.
Yeah.
So closed triangle means if it is forming a closed triangle, that means the body is in equilibrium. Statics means what? There is no movement. The body is in equilibrium. So the sum of forces and reactions acting on the body is equal to 0. That is the normal equation for statics. Like net force is equal to 0, net moment is equal to 0. So there we have used this principle of vector addition.
Yeah.
So let us recap that. Okay. So let us say a vector AB simply means displacement from point A to point B. So let us say this is a vector AB. Okay. So this is vector AB. Okay. Now consider situation that a girl moves from A to B, then the girl moves from B to C. Right? There is a girl who is moving from A to B, that AB is a vector, and then BC is a vector. Okay. So the net displacement made by the girl from A to C is given by vector AC. Okay. So what is the net displacement the girl has made? Okay. So that is given by AC. So that is given by AC. Okay. So here, so this AC vector is called as addition of AB plus BC. So this gives the net displacement. Okay.
Yeah.
So you started from here. You go to B, you go to C. We are not adding how much distance he has covered. We are finding out the net displacement.
Yeah.
Okay. So, so AC is the net displacement. This is called net displacement. Not like you are not measuring a magnitude of this. No. You, for finding the net displacement, you have to do vector addition.
Yeah.
Okay. in general, if we have two vectors A and B and then to add them, they are positioned so that the initial point of one coincide with the terminal point of the other. So this is very important. Okay. So let us say yeah. So to do a vector addition, the initial point of one vector has to you have to go to the
tail to head.
tail to head. So let us say this is a vector B. Okay. So this is a vector B. Okay. And then you have a vector A. Okay. You have a vector A. Okay. So vector A, vector B. So now you want to add vector A to B. So how will add? So let us say this is the final point of A.
Yeah.
Okay. Now you move this B
It's
parallel to it.
Yeah.
You just move it parallel to it so that it coincides with the end point of A or the tail of A. So the head of B, the tail of B is the final point of A is matching with the initial point of B. So this is you draw something like this. Okay, it is almost parallel.
Yeah.
Okay. So now you know A, now you know B. Okay. So that knowing A and B, so this is this. Okay. So knowing A and B, now the closing line will be the addition. Okay. So that will become the C. So C is equal to
Vector A plus vector B.
This is called the vector addition. Okay. So you have to coincide with this thing. Okay. So this is how the vector addition we do. Okay. So that is about vector addition. Okay. So there are some examples given on vector addition that you can practice actually. So there are some laws related to vector addition, like vector addition are like they are cumulative in nature, they are associative in nature. Okay.
That and all I'll see example.
So cumulative means what? A plus B is equal to B plus A, right? That is cumulative, right? So vector addition is cumulative in nature. Vector addition is also associative in nature. So A plus B plus C is equal to A plus B plus C, right? This is called associativity law of vector addition. Okay. So okay, so you can follow. Now it is clear. You can refer this example. There is not much here. Okay. Then there is something called multiplication of a vector. So we have now completed vector addition. We have defined what is vector and the direction cosines and also direction cosine. You always know that x by r. Okay, r is nothing but
Direction.
square root of x square plus y square plus z square. So that is direction cosine. And another is L square plus m square plus n square equal to 1. So L is your cos theta, y is your
Cos beta,
cos alpha. So L is cos alpha, not cos alpha. M is cos beta, and n is cos gamma. Okay. So L square plus m square plus n square is equal to 1, and alpha is equal to cos inverse
x by
r. So these are some of the things you have to remember. And r is equal to x square plus y square plus z square.
Whole root.
And okay, so yeah, so okay. So now multiplication. So till this point we have studied the addition. Now multiplication of a vector by a scalar. Okay, so if you multiply a vector by a scalar, it will become it will become a vector. Okay. Suppose I am saying a vector A. Okay. Vector A into 5. Okay. That means it will become 5A. 5.
5 times that.
5 times 5A. Right. 5A. That is, I am multiplying the vector with a scalar.
Scalar.
Vector and the scalar, the product of A by the scalar lambda is equal to lambda A. Okay. Lambda A. So, and this product is collinear with A. So the direction is not going to change, only the magnitude will change, right? The magnitude will change. So if A is a vector, then 5A, which is a multiplication of vector A by 5, that is also a vector. So direction of 5A and direction of A are
Remains the same, magnitude.
Only magnitude will change. Okay. So that is about multiplication of vector. Okay. So there is something called unit vector. Okay. So actually, what is unit vector? So let us say I have a vector A. Okay. I represent this vector, unit vector, as A cap. Okay. Any unit vector. So unit vector is represented by A cap. Okay. A cap. So this A cap is nothing but A cap. So unit vector is always a vector, that you remember. So A cap is equal to vector A divided by magnitude of A.
Yes.
Okay. So that suppose you earlier we had done like some point P, okay, x, y, z, and some point P in the 3D. Okay. So it will have a coordinate x, y, z. Okay. So what is the unit vector OP? So let us say this is in 3D. So I have a point OP. So what is the unit vector OP? Let us say unit vector and there is a cap. Okay. Then this will become OP vector, whatever, OP vector, how it will be defined? OP vector will be defined as, like say, x I cap, y I j cap, plus z k cap. So that is how a vector in 3D is being represented. Yeah. Like this I cap is nothing but your direction, right? Cos alpha. Yeah. I cap shows your direction vector. So your unit vector will become OP divided by magnitude of OP. Magnitude of OP. Okay. Yeah. So what is OP? So it is OP divided by square root of x square plus y square plus z square. That is your magnitude. Yes. So a unit vector is again a vector. Okay. Like say somebody says my OP is equal to 4i, okay, plus 5j plus 6k, right? If like this I am writing, then somebody will ask what is your unit vector? Okay, like the unit vector, it will be 4i plus 5j plus 6k divided by 4 square plus 5 square plus 6 square. So this is the unit vector. Yes. So unit vector is a vector, but its formula is the vector divided by magnitude of the vector. So if you divide a vector by magnitude of the vector, it becomes a unit vector. Okay. This is very important. This is very, very important. What is a unit vector? So unit vector has magnitude 1. That is one another thing. Unit vector has magnitude 1 and unit vector is vector divided by magnitude of the vector. So with this, we take a picture of this. Okay, so there are, we'll solve some examples. So addition of vector is cumulative and associative in nature, right?
Yes.
A plus b is equal to b plus a plus b plus c is equal to like bracket a plus b plus c or a plus b plus c. So that is cumulative and associative, right?
Yes.
And then we discussed about unit vector, which is vector divided by magnitude of that vector. Okay. Then so there is a question: find the value of x, y, z that two vectors are equal. Okay. So there are one vector. So some numericals will solve. Okay.
Okay.
Some numericals will give you better idea. Okay. So I have a vector a is equal to xi plus 2j plus zk. So this is a vector, okay. Then I have another vector. 2i plus yj plus k. Okay.
Okay.
So the question is, find the value of x, y, z to make a and b equal.
Okay.
So for two vector to be equal,
The
their
magnitude.
magnitude and direction should be same. That means for a and b to be equal, x has to be equal to 2. There is no other way.
Yeah.
Okay. Similarly, y has to be equal to 2. There is no other
To
way.
be equal to
And z should be equal to 1 because there is no coefficient. If this is the condition, if it satisfies this condition,
They
then
are
only
equal.
these two vectors are equal.
Yes.
Okay. So this component of these I, whatever coefficient of I has to be equal. Otherwise it will not be same.
Yeah.
So always for two vectors to be equal, these coefficients of I, j and k has to be same.
Equal.
Very important, that is. Okay, so there is another questions, like another example, like let us say A is equal to I plus 2j. Okay, A is equal to I plus 2j, B is equal to 2i plus j. Right? So the question is whether the two vectors are equal. But if you see the magnitude of A, okay, what is the magnitude of A? It is nothing but 1 square plus 2 square square root. Square 5. So magnitude of B is equal to 2 square plus 1 square square root, which is 5. So magnitude is same, but direction is not same, because 1 is not equal to 2. 2 is not equal to 1. The coefficient of I and j are not same for both these vectors. That's why these two vectors are not equal. Okay. Okay. Then find the unit vector in direction of. So now another example. So this is example 1. This is example 2. So now let us do another example. So it is to find the unit vector of a vector A. Okay. So let us say the vector A is, let's say the vector A is 2i plus 3j plus k. 2i plus 3j plus k. Okay. So 2i plus 3j plus k. This is my vector. So put a cap. Okay. These are all unit vector. Okay. Cap. Okay. So find the unit vector in. So this is my vector. So I know my unit vector is a cap. Unit vector is a cap. E is nothing but that vector by magnitude of that vector. Okay. So what is that vector?
2y
2y plus 3j plus k. Okay.
by root.
Divided by square root of 2 square plus 3 square
Plus 1
plus 1
square.
square. Okay. So this is 4 plus 9, 12, 13, 14. Okay. So it will become
2 by root 14 I cap plus 3 by 14.
2 by root 14 I cap plus 3 by root 14
J cap.
j cap plus 1 by root 14
K cap.
So this is your unit vector.
Okay.
So okay. So another numerical is there. Find a vector in the direction of vector this that has magnitude 7 units. So you you want a vector with a magnitude 7 unit and in a particular direction. Okay. So the unit vector you can find out, and you multiply that unit vector with that magnitude, you will get the vector. So the question is question number 4. Okay. Question number 4 is find a vector in the direction of vector A. So A is a vector. Okay. A is a vector I minus 2j. I minus 2j. Okay. This is a vector. The question is find a vector in the direction of vector that has magnitude 7 unit. So magnitude, that vector will have magnitude 7 unit. 7 unit.
Okay.
Okay. So in this case, we will have to find out the unit vector. You multiply the unit vector with the magnitude, you will get that vector. Okay. So first, what is the unit vector? Unit vector is nothing but I divided by 1 square plus 2 square square root, which is nothing but 5 square root.
Minus 2.
Minus 2 5 square root divided by
J.
Into j. Then this is the unit vector. Then you know magnitude is 7. Okay. So this 7 into unit vector is nothing but 7 by square root 5 I minus 14 by 5 j. Clear? So this is the vector which has magnitude 7, right?
And is
This is in the direction of this.
that A vector.
So 7 by root 5 I and 14 by root 5, sorry. So this is very important. You can get some question like this.
Yes.
So find a vector of magnitude this and parallel to this vector. Find a vector of magnitude this and parallel to this vector. So first you have to find that unit vector and multiply with the magnitude. The question, find a vector in direction this, in this direction,
Which has
that has magnitude 7. Okay. Okay, so another question is like 1, 2, 3, 4, 5. So question number 5. Okay. So question number 5. Find the unit vector in direction of sum of vectors. So we have two vectors. Okay. A is equal to 2i plus 2j minus 5k. So 2i plus 2j minus 5k. And we have another vector 2i plus j plus 3k. 2i plus j plus 3k. Okay. Okay, so a plus b will become just addition. Okay, 2i plus 2i, 4i. Right?
Yes.
Right? Then 2j plus j is 3j. 3j. J. Then minus 5 plus 3 minus 2k. So a plus b is a vector which is nothing but 4i
plus
3j
minus 2k.
So this is you got 4i plus. So now the question is find the unit vector. So you know, like say a plus b, and this is unit vector means you just put a cap on it. Okay.
Yes.
You then A plus B divided by
magnitude.
of excess B. Okay. So you know, like A plus B is nothing but your 4 by what is the magnitude? 4 square plus 3 square plus 2 square. So 16 plus 9, 25 plus 4, 29. So 4 by square root 29I plus 3 by square root 29J minus 2 by square root 29K. Okay.
Yes.
So this is your vector. That this is nothing but your unit vector.
In direction of the sum of those two vectors.
So 4 by 29, so that is what is mentioned here. Okay.
Okay.
So these are some of the things you can practice. There are some good number of practice problem you can see, like some 20 problems which will be very easy that you can do.
Okay.
So now we are done with addition of vector, subtraction of vector, multiplication of vector by a scalar. So we have gone up to multiplication of vector by a scalar. Now next point is multiplication of two vectors. Okay, that is the only thing remaining we'll cover in the next class.
Okay.
So when you multiply two vectors, one is called dot product, one is called cross product. So what is dot product, what is cross product, that we'll cover in the next class. But we have covered a lot of concept today. Okay, you can practice at least 50-60 problems from your book. What is unit vector and all that. So to understanding unit vector is very much essential to understand this dot product and cross product. Okay. So you practice. There are some in the page 440. There are some 20 numericals are there. You practice.
Okay.
Understand what is unit vector and all. Okay. So we will cover in the next class the dot product and cross product. Okay. Thank you.